We should be live. Hopefully this all works. Hi. Quite the new setup here. The plan right now is to just do a quick test stream for the next 45 minutes or so. Do a couple things, make sure chat works, make sure everything else works. And then after breakfast, I will be back for the rest of the day. And then this is going to be my schedule for quite a while now. Just trying to fix the next release, fix up PufferLib, fix up all the stuff for next release, and then we have a lot of research planned from there. So there will be a lot of stuff to go through quite soon. But I think for now we're just going to start looking at some of the latest experiments. Let me just make sure this thing is actually working. Seems to be. Okay. So here's the plan. This is the current best performance on Neural MMO3. I usually go by this metric here, which is the same shape. This is a run from last night that is probably going to do a little bit better, though at the price of being quite a bit slower. I'm going to have to run this thing for longer since it was running on my local. This is another run that probably should have done better than this, and it is interesting that it didn't. So I think what we will do right now to get started, I'm going to set up a couple of new runs. This place is kind of fun. We have capacity for a whole bunch of new boxes back there. You can see I just have one on there now, and there are 4 more shelves that we can put together for this. So that's going to hold 40 boxes, but I have to wait for tariffs to come down in order to buy those. But for now, we're just going to start launching some runs on there, make sure our new setup is stable, make sure everything is good, see if we can set a little bit of a perf increment on Neural MMO3. And then what I want to start doing today and tomorrow is really doing a big refactor on the Puffer training scripts, to make them way easier to use, to make them more self-contained, and also to get them into the Puffer pip package. You can just pip install Puffer and start training. I don't want to commit to like an abstracted RL API though. I think it's too high level, it's the wrong move. So I have to balance those two things. I think what's going to be cool over the next couple days is that anybody dropping by stream is going to be able to give input on, how the new transcript should look, where they should go, what's going to be easiest to use, that type of a thing. We'll have these runs going in the background. And then the only other small wrinkle, I have a couple meetings, and then there's one environment that seems to not be working suddenly, and I don't know if something broke in Puffer or if something broke in the environment. I would suspect the latter because looking at these curves, these match what I would expect on Neural MMO3, so we are probably good here. Yeah. And I don't know if I actually want to keep... I guess I should probably... Let's do this run for longer to see how this changes over time. We'll kill this one, and we'll come back to this. Yeah, so we're now training at 650,000 steps per second with a 2.4 million parameter model on here. So this is what I did for the run that did better. I just increased the number of channels. Yeah, same as there. And then here, what I tried to do was something a little different. I tried to go with an entity encoder for all the different attributes. So if you look here, there's this max. This was going to cut down the network size quite a bit, but for some reason, that seems to do way worse. So I will have to think about why that is. But in the meantime, yeah, the non-entity encoder just blows up the size of this hidden layer, unfortunately. But we will do this for now. So we have 256 hidden, and I believe that this should do, this should actually run. We will see. Quick test without Neptune. I gotta figure out why the NVIDIA drivers just occasionally crash. That's kind of jank. I mean, it's not that hard to fix. But it's a little silly. So if anybody knows why that happens, occasionally just Docker loses access. You can let me know. Yeah, so 4.2 mil parameter model, and I forgot one other thing. Just left over. And I'm not seeing the chat, but I think it should be working. Yeah, there we go. Hey, Captain. Up close and personal? Well, we'll see if that stays. It's very difficult to actually get this set up correct, because I also have this whole big microphone and pop filter on a boom arm. So we got to figure this out. It's a little close. Interested to see pics of the setup? One moment. The thing is, we still need all the new machines, right? So I just have the one box on there at the moment. But it does work, and it's very nice to wire stuff. So as soon as I get this run going, I think the camera will autofocus. I also would like to check if this compile even does anything with the optimizer. Okay, so there we go. So that's still 500K on the nicer GPU. Okay. So you can see, yeah, I have it in the shot. So right back there, we have one of the boxes. That's the first 5090 box on there. The wiring isn't in the shot, but you can kind of see in the background with all those rails, we've got 40 outlets there, and there's room for 4 of those additional racks, and then there's also room for, yeah, you can see the server frame, like the open frame back there. That's got UPS, that's got switches and stuff, and then that will contain anything else that we acquire. So we have plenty of capacity for hardware now, and the GPU machine is just going to be a matter of when tariffs come down. Are all the puffer boxes up now? They should be, except for 6. That went back to main gear for maintenance. But yeah, for the 40, I mean those can get here pretty quick, I'm told, like just 3-4 weeks lead. But the tariffs are like plus 40% price on all of them right now, so I'm hoping that those are going to come down. Okay. So we have this run going. Rack is nice, diagonal pull-up bars. Yeah, those are fun. They're a little sketchy, because you're pretty high up if you miss. So I'm just messing around on the bottom too, getting used to it for a bit before I do the whole thing. This is also not all the equipment yet. Right now we just have the big rack. There's the bench. I got like an adjustable bench, and I've got a log. More stuff is going to be arriving. Puffer training facility. Training for me, training for RL agents. All right. So the thing that I want to get started on, at least, just to get a start on for now, I think I want to merge this with demo. Interesting project. What was the most valuable thing you learned during your time at MIT? Oof. Man, that's a hard general question. Probably just getting a perspective on how academia operates and where the way that academia operates is effective, but then also where it isn't. So knowing where to look for major gaps, and like surely all the world's top scientists didn't miss something. No, yeah, they absolutely did. And knowing how they operate so you can identify places where that's going to be the case. I mean, PufferLib is something that I just could not have built really in academia at all. And it was really using that, that insight after I graduated that took me down this direction. So this is what I want to do. This is a little crazy because this is already an 1100 line trainer file. And I do want to compress this a whole bunch, even though, a lot of this is just like perf monitoring and stuff. But what I would like to do here, I want to combine this with the demo file, which is 381. So that gives you about 1500 lines. And then I think there's 1 or 2 other things. I think some of the PyTorch utils maybe can just go in here as well. Maybe not. Maybe it is just those 2. We'll see. I think the only thing we're using from utils is this like tiny function, right? And then, yeah. So there are a couple things here. I think we can get this to the point that it's, other than using, our base models and stuff like that, it's pretty self-contained. And then the point of doing that would be that we could then put this as a single file into the pip package. Let me show you what I'm sort of thinking there. And this is one spot that I definitely want user feedback on what's going to be easier for folks. So the way we have this set up in 2.0, we have this pretty small top directory that has a few scripts for you. So this has generalized advantage estimation. This has like a couple CleanRL demos and a few utilities. And what you do is if you just want our environments, you can pip install it. But if you want to use our stuff for training, then you have to clone it. And I think most people are going to want to clone it anyways, because as soon as you want to do any research and hack on stuff, you do need the source code. But I think for people who are just like trying to run our trainer or run our stuff on new M's and don't really want to be doing a research side stuff, kind of just tinkering, we could probably make it pip installable, including the training. That doesn't mean I want to commit to an API necessarily, but we could put the demo behind like an entry point in the pip package. So you could just do like puffer train or something, and it will just call that file. And if we're gonna do that though, I want that to be like as minimal as possible. I don't want to have like an ever expanding folder and then we become like a RL API. And I think that the main impetus for this is just like how much better our train demo has gotten. When I started Puffer, I thought it was going to be low-level utilities around M's and training and stuff. And what's happened since then is like we've just eaten the whole stack. And now our implementation is just so much faster than everything else that you're probably going to want to use Puffer. So, I mean, we could have something in here. We could have like clean PufferLib in here. Some of this stuff could get squashed. Like this folder will get smaller. Let's see how it is in dev. We do have some CUDA stuff, so there will have to be like some CUDA stuff in there. I could just put it all inside of like a PufferLib train or something, right? The thing that I don't want, right, is I don't want PufferLib to become like, I think it's either too early or entirely the wrong idea to try to like here. Look at all the libraries that have tried to do this. So like here, stable baselines 3, they tried to modularize stuff. This is like one of the common ones. It's really slow. It's really hard to hack on anything that's not covered. And ours is just like faster and better with a tiny amount of the code at this point. Like you don't need all these implementations if this one is just better and works and is faster. So like a lot of the different libraries, like they kind of want to have all the different algorithms, and then they try to come up with, yeah, look at all this stuff. And then they try to come up with like ways to make them all play nicely with the same experience buffer or stuff like that. I don't want to do that. Yeah, I don't want to do that at all. I want to go the opposite direction. I want it to be a lot more like CleanRL and get as like close to this simplicity as we possibly can. So like this is CleanRL's PPO, and they only have 286 lines here. I guess 329 counting white space and stuff. And it's like so simple. So I really want to get closer and closer to this. Well, of course, we have stuff we have to handle in order to make it fast. But as close as we can get to this level of simplicity, the better. Now, I don't think, like this, you're literally just intended to edit this one file. And then this one file is kind of like one environment, one experiment, whatever. So we want a little bit more flexibility than that. I'd like to be able to run this on different environments and on different policies. So instead of just having the environment hard-coded and the policy in here, I'd like to be able to load in a different environment and a different policy. I would like RNN support, so maybe I should compare more to this. There's only 375. But it bothers me that we have so much more code than this. And I know why everything is there, but still. Because so first of all, we have this eval train split, right? You don't just run the script, you run eval and then you run train and you run eval and you have run train. And that's done that way so it's easier to evaluate existing policies. And it's kind of fine. This whole namespace thing is ridiculous. That's 45 lines right there. We've got all this different optimizer config. We've got all this LSTM, non-LSTM stuff to support both. We've got P30, which is still work in progress that I need to go back to. And all these things kind of add up and just add a bunch of bulk. Now, the one thing I was really proud of lately is I did fix our profiling. So our profiling is very light now. You just have a few lines and you get comprehensive profiling. So most of this stuff is not too much overhead over CleanRL. And I think once we evaluate Diane and we evaluate P30 and figure out what matters there, this will be pretty close to comparable. Stuff like this I can definitely crunch up a little bit if I try. And then this whole block is P30. So I think once we really know what we need to keep and what we don't need to keep, and we kind of just keep the one path that we really want, we can cut out a lot of this stuff. A lot of this extra that's been in here is just not really needed. It's going to be a lot of experiments to figure out for sure what matters and what doesn't, but we should be able to do that. Experience buffer stuff maybe can compress a little bit. This is more experience buffer stuff. We have distributed, we've got logging. And now we are at 750 lines, of which we can probably delete 250, at least. And then we have features that CleanRL just doesn't have, right? They don't have checkpointing, model saving, and loading stuff. We have this eval mode, so you can run rollouts. And then we have profiling, quite a bit of profiling, and the dashboard. All this is just to print the little local dashboard. So this type of stuff, probably there's not much to save. So this is going to be 200-ish lines. Yeah, so there's 200 lines of profiling at the bottom. And another almost 200 lines of utils. Okay. Well, I'm not too beat up over those. It doesn't make sense to have a line target or anything for this. That's kind of just stupid. But I think that the thing is going to be to just put the two files together and then just try to remove anything that is redundant. Most of the redundant stuff looks like it comes from optional args of supporting different settings, where really we want to run all the experiments and only support the settings we care about. So that should get better. And then what about the demo file? The demo file has WANB and Neptune. We do need to support both of those. This policy load stuff can get simplified. Sweep configs, already pretty simple. Maybe we can do something for this. We probably can totally do something for this, right? Yeah, we can totally do something for that. Carbs will be gone once we have evaluated it thoroughly, because I'm sure we outperform that. Got this training stuff, some little jank injection, whatever here. Backend stuff. I think a lot of this like multi-selection thing we can probably do much more easily without having all this. Like we can probably just dynamically load whichever one you have in the config. We have DDP. Here's the loop. We have this like jank data collection thing on like downsampling the trajectory for protein. Whether or not that's useful, we'll have to see still. Yeah, this downsampler, DDP, and then 230 down to 381, so 150 lines of just main file. Setting up argparse, reading configs, this bit here, and then calling all the associated methods. Well, no time like the present. And now we see all the stuff that we also import from PufferLib here as well, right? Yeah, this is much easier. Okay, we've got rich. And now we're no longer calling this externally as if it were like some API. $14.73 starting lines. And this should work already, unless there are name conflicts. Missing 4 arguments. Yeah, so there is a name conflict here. So it is, the fact that we have this wrapped trainer is interesting. As ridiculous as this is like one of my favorite things to do, is to just paste all the code together and then like see what ends up being redundant when you have everything next to each other. It ends up being ridiculously effective. So like I do end up with very long files as a result of that. But like I end up with one file that is a third of the length of the 10 files you would have written otherwise. Okay, so there's breakout at 3 million steps per second. That is a 26-second training loop. And this already runs. So I would like to ideally do this without introducing any major bugs, which means smaller little refactor hops than I would normally do. And for reference, the plan here is I just wanted to get like the test stream in this morning, the whole new setup here. And then I will be back for the whole rest of the day after breakfast working on this. Minus or modulo one, I believe one call in the mid-afternoon. So what is there, okay, here's another question, right? What is there in here that I can cut out that is not related to me supporting like more options that I have not thoroughly evaluated yet? Because we know that there's like different advantage functions and stuff like that. But what is there in here that's just like ridiculous? I mean, the way that I have this create function, man, I really hate to admit that this should probably just be a class. Because this thing at the bottom that's like a data, like this thing is ridiculous here, right? And yeah, I can get rid of a lot of these, but still. I guess what I was going for here, right? It's so easy in CleanRL because they just have this one function and everything is just global. You see? Like everything is just global. So they don't have this issue. But if you actually figure out and like try to pass everything that you need for eval and everything you need for train like separately, the signatures of these get gigantic. So I stuff this into a giant data structure, which then obviously grows and grows and then like accumulates everything. Okay, what are options? Option one is leave it as is. Option two, just bite the bullet and convert this to a class. Then each of these things would get assigned when they're needed. Option three would be to create this thing dynamically. So like I can assign stuff to this after it's made. That's kind of just like making it sort of like a dictionary. The original reason that I didn't want this to be a class was what? Was it literally just the indenting? So you go train or other than this, like most of this is pretty reasonable. I think that what happened was before, like, because we had all the profiling code indenting, I thought it was just getting to be absolutely ridiculous. Like you're writing code halfway across the screen. It probably wasn't a great reason to do this, though. A lot of this is also kind of left over because, like, this is a language thing, right? Like, I know how I would do this in C, and it would look pretty similar to this, except that there'd be a struct, because that's how you would have to do it in C, and it would be very simple, right? Because everything that's 0 would default to 0, and the actual creation of the struct would be smaller. But that's not really how Python works. I guess technically I could put it as a data class. I've not liked those in the past. I mean, this is basically a struct, right? This does not feel good to me, though. You know, I think the reason I like this in C and not in Python is because C is typed, right? So I would have this function not be a part of the data class, but then it would take the type, which is inventory item. So here it's like this data class is kind of... Hang on, do you even need data class like this? What does data class even do? I thought this was changed. Yeah, so you don't even need that data class annotator. Okay, so... You know, I agonize over, like, these little details like this. This is probably the 5th time I've thought about this. But it matters a lot. Half of this is me fighting against, like, me wanting to write C in Python, which is just not smart. The other half is me fighting against, like, doing it the really dumb Python way. Okay, so what if I just made it... What if I just took all these things that have obvious defaults, right? Okay, so what if I make this thing a class? I have all these things that are, like, obvious defaults. All these zeros and things. I can put those up top. What happens if you have, like, this be an instance of a class? Does that happen? Like, does that work? Like... Hmm. Oh, I think it was because you can just do... Yeah, you can't do this. That's what data class gives you, right? And we don't need that. So, okay, what would this look like then? A lot of these, this junk, right, would be at the top. And then we would have an init function that sets all this. A lot of these things don't even necessarily need to be in an init, though. Like, this is a global, right? Like, this is a global setting for torch. Putting it inside of this function doesn't do anything. The seeding stuff, yeah, because there's a seed that you can set. I don't even know if we need to do that, though, because, like, realistically, you're not getting that same curve back anyways. Maybe you are. I guess it depends on whether you're MC'd correctly. Okay, so I think what I'm gonna do, I'm gonna go get breakfast in a minute here. Yeah, like even this losses thing is kind of ridiculous. Okay, I'm gonna think about this a little bit over breakfast. I think that the main thing for this is like figuring out what we do with the structure of this whole training code. Because everything else, for the most part, I mean, at least a lot of it is just us supporting a ton of settings that we haven't decided which ones we want to keep. Yeah, I think that over the next couple days, the plan is going to be to see if we can really condense this thing down into a nice, simple, easy to use single file transcript for PufferLib. So if you want to be a part of that and you want to give feedback on how this thing should look and what would be the easiest for you to use in Puffer and how HyperRL should work, then you can drop by the streams for that. I'm gonna go get breakfast. I'll be live for pretty much the rest of the day outside of one meeting, and then all day tomorrow as well. And pretty much this is the schedule going forward. I'm back to dev, and aiming to try to finish up the next release over the next few weeks. Get something shipped, get a whole bunch of stuff written on that as well, which I'll probably also deal on stream, because why not? And other than that, yeah, I have some research ideas for after the release, but I think the initial goal is just ultra high performance, really stable, hyperparam robust, easy to use next version of PufferLib. And I still haven't decided on a version number for that. So thanks for dropping by. I will be back in probably only like half an hour or so. If you want to check out all this stuff, it's all open source at puffer.ai. You can start on GitHub to really help us out. You can join the Discord to get involved with dev. Most of our contributors came in with 0 RL experience and are now doing really awesome stuff, really cutting edge RL stuff. So thanks, and I will be back in a bit.